Alright, we're taking a look now at two fire towers that are situated at points A and B. They spot a fire at angles of 42 degrees and 64 degrees respectively. If you're not familiar with the wording respectively, that just says in the same order. So A and B in that order means that the A tower corresponds to the 42 degrees, the first one listed. The B corresponds to 64 degrees. So just be mindful of that word respectively. It asks how far from the fire is Tower A if the towers themselves are 10 miles apart. So we only care about one distance in this problem, but we've done one in a previous video very similar to this. It's saying that points A and B, or towers A and B, are 10 miles apart, so we'll put a little 10 miles here. And they've both spotted a fire somewhere out here. My camera seems to have gone a little bit out of focus again. That's alright, we'll fix that as we jot this down. It told me that we had a 42 degree angle here. It told me we had a 64 degree angle here. And if you watched the previous video, you should already know where we're going to end up. Because for this one, we know that we can find this angle down here by subtracting these other two angles from 180 degrees. So when we do that, we're going to see that we have a 74 degree angle at the bottom. And you might start by saying, well, what good is that going to do me? It didn't ask about that angle, and that's okay. The big thing here is we're trying to identify a side length, but we already have another side length given. We've got two angles provided. This is telling me law of cosines is really kind of out of the picture here. We need this other angle to use law of sines, though, because we need a pair of side and angle. We need an opposite pair. So the 10 miles is opposite the 74 degrees. Without that opposite pair, law of sines falls apart. But it did ask me how far Tower A is from the fire. So let's just call this a little a for the distance Tower A is. And I know this is, again, kind of opposite convention of what I usually use for generic triangles. But just so I know I'm talking about Tower A, we're going to say that Tower A is some distance away, and that distance will compare to its opposite angle, which is 64 degrees. And then we're just going to go in with our given pair of information and say that the 10 miles corresponds to the angle of 74 degrees. And we're basically done. We just need to bring up our sine of 64 by multiplying it to this side. And at that point, we can grab a calculator and figure out an approximate value here. Now this one did not ask me how to round, so I'm going to go with probably 1 or 2 decimal places. We'll see what it looks like as best for this particular problem. And on this one, I'm not going to worry about inserting any fraction bars because, realistically speaking, that one's not too bad. And when I go to choose how I want to round, if they don't tell me, I often look for indicators that are helpful. Noticing the 0 here, this is a very clean spot to cut this problem on the rounding. So I'm going to round this to 9.35 miles. Just because that 0 means I don't have to worry about rounding up or down or anything of that nature. I can just leave it the way it is very easily. And there we have it. We have 9.3 miles is the distance that Tower A is away from our fire.